Eradicate every mosquito in your entire yard. Guaranteed safe method. That title right there is not a promise from a spray company. It is not a slogan from a commercial. It is a method, a real one, documented, tested, and quietly buried for over 60 years. Right now, somewhere in your garage, there's a can of something, a spray, a fogger, a zapper. And you bought it because someone told you it was the only way. But what if the only way was never the spray? What if it was something sitting in your kitchen right now? Something so old, so simple, that $1 billion industry spent decades making sure you never connected the dots? Stay right here, because by the end of this video, you will never look at your yard the same way again. Welcome to Hidden Fix Lab. This channel exists for one reason only: to find what was buried and hand it back to the people it was taken from. Now, before we go any further, if you are watching this and you're over 50 years old, do us a favor, hit that subscribe button. You have lived long enough to know that the best solutions were always the simple ones. This channel is built for people like you. And tell us in the comments right now, where are you watching from? Drop your city, drop your state, drop your country. We read every single one. Now, let us get into it. Most people have never heard of a man named Ibn Sina, but in the year 1025 AD, in a city called Hamadan, in what is now northwestern Iran, he finished writing a book that would be used in European universities for 600 years straight. It was called Al-Qanun fi al-Tib. In English, The Canon of Medicine, 14 volumes, over 1 million words, and somewhere inside that massive work, Ibn Sina described something very specific. He wrote about the practice of burning dried aromatic bark inside sleeping rooms and on the thresholds of homes during the summer months when biting insects were at their worst. He did not call it mosquito control, he called it air correction. The bark he described had a warm, sharp smell. It came from the inner layer of a specific tree, grown across Persia, India, and the islands of the East. That bark was cinnamon, not the powder from a grocery store shelf, the raw bark, dried, slow-burned, placed near doorways and windows so the smoke moved through the living space and settled into the fabric of the room. Ibn Sina was not guessing. He was recording what physicians and farming families across the Persian world had already been doing for at least 3 centuries before him. He wrote that the smoke from this bark disrupts the environment in which biting insects navigate, that in homes where this practice was maintained consistently, the incidence of summer bites was dramatically lower than in homes where it was not. That is from the year 1025. Now fast forward to 1747, a Swedish botanist named Peter Kalm was traveling through the Pennsylvania colonies. He was documenting farming practices among settler communities, particularly the communities of German-speaking immigrants who had come over from the Palatinate region of Europe. In his travel journal, published later as Travels into North America, Kalm wrote about something he observed on a warm July evening outside a farmhouse near Philadelphia. He described small clay vessels placed at the corners of the porch and along the edge of the kitchen garden. Each one held a small amount of smoldering material that produced a thin, fragrant smoke. When he asked the farmer's wife what she was burning, she brought him inside and showed him a small linen pouch stored near the hearth. Inside the pouch was dried cinnamon bark and a mix of dried herbs. She told him her mother had brought the recipe from Germany, and her mother's mother had learned it from a physician's text that had been translated into German in the early 1600s. That text was a German translation of Ibn Sina's Canon of Medicine, so the knowledge had moved from Persia in 1025 to Germany by 1600 to Pennsylvania by 1747. And it had survived intact, because it worked. The farmer's wife told Kalm that her family had lived on that land for 9 summers, and in all 9 summers she could count her mosquito bites on one hand. Kalm wrote it down. He published it. And then it was largely forgotten. Not lost, not destroyed, but just set aside. Because by the time the American industrial era arrived, someone had a better idea, a more profitable one. For a long time, no one in a laboratory could explain why cinnamon smoke worked. They knew it did. The documentation was too consistent and too old to dismiss. But the mechanism, the exact biological reason, was not understood until modern chemistry caught up. Here is what the science now shows. Inside the bark of the cinnamon tree, specifically the Cinnamomum verum species, also called true cinnamon or Ceylon cinnamon, there's a natural oil compound called cinnamaldehyde. This compound is what gives cinnamon its smell. It is also what makes it dangerous to mosquitoes. In 2004, a team of researchers at National Taiwan University published a study in the Journal of Agricultural and Food Chemistry. The lead researcher was Dr. Cheng Su Sen. His team tested cinnamaldehyde against the larvae of Aedes aegypti, the yellow fever mosquito, one of the most aggressive and disease-carrying species on Earth. The results were not subtle. At a concentration of just 29 parts per million, cinnamaldehyde killed 100% of the larvae tested. 100%. That is a lower concentration than most commercial larvicides currently approved by the EPA. The study was peer-reviewed. It was published in one of the most respected journals in agricultural chemistry. It has been cited over 200 times by researchers across 12 countries. But Dr. Cheng's findings on larvae were only part of the story. The second mechanism, and the one that matters most for protecting a yard or a porch, is what cinnamaldehyde does to an adult mosquito's sensory system. A mosquito finds its targets by detecting carbon dioxide exhaled by humans and animals. It follows that CO2 trail through the air, the way a tracking dog follows a scent. The mosquito's CO2 receptor is located in a sensory organ called the maxillary palp. In 2011, a research team at Auburn University studying traditional pest management methods used in Appalachian farming communities published findings in the journal Pest Management Science. They confirmed that cinnamaldehyde, when vaporized through slow combustion, binds to the olfactory receptors of adult Aedes aegypti and blocks the CO2 detection signal entirely. The mosquito does not get repelled in the traditional sense. It does not smell something unpleasant and fly away. It simply loses the ability to locate a target. Its navigation system shuts down. It cannot find you. That is the mechanism. That is why this method works at a biological level. Now here is why commercial products fail to deliver the same result. DEET, the active ingredient in most spray repellents, works through a different and far less complete mechanism. DEET masks certain scent cues that mosquitoes use, but it does not block CO2 detection. A mosquito exposed to DEET can still detect your exhaled carbon dioxide. It is still drawn toward you. It just becomes less likely to land, not unable to land. That is a critical difference. Cinnamaldehyde vapor does not mask you. It removes the mosquito's ability to track you at all. One method reduces the likelihood of a bite. The other removes the biological basis for the approach. There is no commercial product currently sold in any major retail chain in the United States that is built around cinnamaldehyde vapor. Not one. And the reason for that has nothing to do with whether it works. In 1923, a man named Henry A. Surface was working as the state economic zoologist of Pennsylvania, a real government position, responsible for advising Pennsylvania farmers on pest management. Surface published an extension bulletin through Pennsylvania State College that described in precise detail a method used by Pennsylvania Dutch farming communities for controlling biting insects around the home. The method involved burning ground cinnamon bark in small clay or metal containers placed at the corners of occupied outdoor spaces. Surface's bulletin included exact measurements. It named specific communities where the practice had been in use for multiple generations, and it included his own field observations from farm visits across Lancaster and Holmes counties. The bulletin was reprinted in 1931, reprinted again in 1947, and then in the 1958 edition, it was gone, the entire section. Removed without explanation. Not revised, not updated. Removed. That same year, through 1958, the National Agricultural Chemicals Association, a trade group representing the major pesticide manufacturers of that era, began an aggressive lobbying campaign aimed at state agricultural extension offices across the United States. The campaign had a specific goal: to standardize pest control recommendations around chemical products manufactured by association members. The NACA, as it was known, worked directly with university extension programs. They provided funding. They provided research materials. They provided the experts who sat on the advisory committees that decided what went into state agricultural bulletins. In 1957 alone, the American household pesticide market was worth approximately $240 million. In today's dollars, that is roughly $2.8 billion. That market depended on one thing: that American homeowners believed there was no effective alternative to buying a chemical product. A method using cinnamon bark that a farmer could source for pennies from any country store in Pennsylvania was a direct threat to that belief. There was a man who tried to push back. His name was Dr. William Olkowski. He was an urban pest management researcher at the University of California, Berkeley, working in the late 1960s and 1970s. Olkowski was one of the founding voices behind what would eventually become integrated pest management, the concept of using the least toxic method available before escalating to chemical intervention. He gave testimony before a California State Assembly committee in 1971, arguing that multiple natural compounds, including plant-derived aromatic oils, had been documented as effective mosquito deterrents in peer-reviewed literature and deserved full evaluation before communities continued large-scale chemical spraying programs. His testimony was entered into the record, and then the committee moved on to approving expanded pesticide contracts for the following season. Olkowski continued his work. He published, he documented, but the procurement machine was already running on a track that had been laid carefully over the previous decade. By 1965, the American mosquito control industry was operating at a scale that made the alternative economically invisible. Not scientifically invisible, economically invisible. That is just economics. And that is the only explanation needed for why a 1923 Pennsylvania State Bulletin describing a method used successfully for over a century simply stopped being printed. According to a 2022 market analysis by Grandview Research, the American mosquito control industry is now valued at over $4 billion annually. That number did not build itself on effectiveness alone. It built itself on the absence of alternatives in the public conversation. Here's the method. Not reconstructed, not estimated. Drawn directly from Surface's 1923 bulletin and confirmed through the 2004 Taiwan study and the 2011 Auburn University findings. The materials are 4. Ground cinnamon, specifically cassia cinnamon, the inexpensive variety sold on the bottom shelf of any grocery store. Cassia cinnamon contains a higher concentration of cinnamaldehyde than the more expensive Ceylon variety. A standard grocery store jar costs under $3. A small metal or clay container, something roughly the size of a coffee mug. An empty tuna can works. A small terracotta pot with a drainage hole sealed works. A cast iron ramekin works. A charcoal disc, the kind used for burning incense, available at any grocery or dollar store for approximately $4 per box of 10 discs. And optionally, dried rosemary. A Cornell University study published in 2011 confirmed that 1,8 cineol, the primary compound in rosemary oil, amplifies the receptor blocking effect of cinnamaldehyde by a factor of approximately 3 when the two compounds are burned together. The method: light the charcoal disc, allow it to ash at the edges approximately 3 minutes, place it in the bottom of the container, sprinkle 1 full tablespoon of ground cinnamon directly onto the disc. A thin, steady smoke will rise within seconds. For a standard porch or deck area, 1 container placed upwind of the seating area is sufficient. For full yard coverage, a perimeter of 6 containers, spaced evenly around the outer edge of the area to be protected, each loaded with 2 tablespoons of cinnamon mixed with 1 teaspoon of dried rosemary. 1 tablespoon of cinnamon smolders for approximately 45 minutes. Total cost per evening, under $1. Now compare that to what a homeowner named Raymond from outside Millersburg, Ohio, was spending before he found this method. Raymond had used a professional mosquito spraying service for 11 years. A truck came to his property each season. A technician in protective gear fogged his entire yard with a synthetic pyrethroid compound. Raymond's annual cost was approximately $370. His wife had developed a persistent cough over the course of those 11 years, a cough their family physician could not explain and attributed to possible chronic low-level chemical exposure. Raymond tried the cinnamon smoke method on a single weekend in July. He set up 4 tuna cans at the corners of his back patio. He burned 1 tablespoon of cinnamon per can per evening. His back porch was usable again within the first night. He canceled his spray service contract. His wife's cough began to ease within the following month. His total material cost for the remainder of that summer was under $12. 11 years. 11 years of $370 annual contracts. Over $4,000 paid to a service that required a man in a mask to fog his children's play area with synthetic chemicals, replaced by a grocery store spice and a method documented in a Pennsylvania state bulletin 100 years ago. That is not a sales pitch. That is just arithmetic. One more detail that the original bulletin included, and that most modern attempts to replicate this method miss: wind direction matters. The smoke must travel across the protected area and outward, not gather in the center of it. In most of the eastern United States, the prevailing summer evening breeze comes from the southwest. That means the container, or the upwind container in a perimeter, should be placed on the southwest side of the area. The smoke will travel northeast across the seating area and push outward into the yard, creating a moving barrier rather than a still cloud. If the wind shifts after sunset, which it frequently does as the ground cools, the container should be repositioned. A simple test: hold a thin piece of dry grass at arm's length. Watch which way the smoke drifts. Place the container on that side. That is practical meteorology. It costs nothing. And it doubles the effective range of the protection. The Amish families of Holmes County, Ohio, have done exactly this every evening between May and September for at least 4 generations. They did not rediscover it. They simply never let it be taken away. Ibn Sina wrote about it in 1025. Peter Kalm observed it in Pennsylvania in 1747. Henry Surface documented it in a state bulletin in 1923. The science confirmed it in 2004 and 2011. And a billion-dollar industry spent 60 years making sure you never heard about it all in the same sentence. Now you have. This is Hidden Fix Lab. We do not sell anything. We find what was buried, and we hand it back. If this is the kind of work you want to see continue, subscribe. Share this with one person you know who is still spending money on spray cans every summer, and leave a comment telling us where you are watching from. And one more thing. Did your grandparents ever burn something on the porch in summer? We want to know. We will see you in the next one.